Honors Geometry people, welcome back. Today we're going to talk about probability with permutations. And our essential question is, how can I calculate the probability of an event? We're going to start with the entrance question. We have 10 pictures, and we're going to talk about how many different ways we can arrange them into groups of 4 if order matters. So you can see here in this little graphic, we have 4 pictures, and we can arrange them differently. So we know that we want to have a total of 4 pictures hanging up on the wall. And we know that we have 10 pictures. So we have in this basket, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first time I go and pick out a picture, okay, you'll notice that I have 10 choices. The second time I go to pick out a picture, you'll notice I have 9 choices. And then I have 8 choices. Followed by 7 choices. Okay, and I can multiply all of these together, 10 times 9 times 8 times 7, and there are 5,040 different ways to take 10 pictures and arrange them into groups of 4. And that's what we're going to be talking about today. All right, so cruising ahead, example 1 says, how many different outcomes are there when you toss a fair coin 3 times? And we could use a probability tree diagram. All right, so when we flip a coin, we know there's 2 sides to a coin. We can either flip heads or we can flip tails. So for the first time we flip, our choices are heads or tails. Once we flip heads, the next time we flip the coin, we have the option of heads or tails. When we flip tails, we could also, for our second flip, get heads or tails. After our second, we can choose to get, or we can flip heads or tails, heads or tails, heads or tails, so on and so forth. And each item in this tree diagram represents an option. So if I toss a coin 3 times in a row, I have one possibility of getting heads, heads, heads. Another possibility of going heads, heads, tails. And then I have heads, tails, heads, heads, tails, tails, so on and so forth. Okay, and if I count them all up, there's 1, 2, 3, 4, 5, 6, 7, 8 different ways to toss a coin 3 times. Now, tree diagrams, while lovely and help you organize your thoughts and give you a nice visual representation, they can take quite a while. So you can think of it this way. So if you're just trying to figure out how many different outcomes there are, the first time you toss the coin, there are 2 possible outcomes. The second time you toss the coin, there are 2 possible outcomes. And the third time are 2 possible outcomes. 2 times 2 times 2 gives us 8. So there are 8 possible outcomes. Now, if you wanted to expand on this and say, what's the probability of 3 heads in a row? Well, looking at my chart, there's only one way to get 3 heads in a row. There are 8 possibilities. So my probability of flipping 3 heads is 1 out of 8. So that tree diagram can help you with that. If you want to know the probability of flipping exactly 2 tails, well, if I look at that, my 2 tails, I have, let's see, 2 tails here, 2 tails here, 2 tails here. If I want exactly 2 tails, that would be 3 out of 8. All right, so cruising ahead. How many different ways can you dress if you can choose from any set of 3 pairs of socks, 2 pairs of pants, and 2 shirts? Okay, pause the video, see if you can come up with a prediction. Okay, so we have 3 socks, 2 pants, 2 shirts. 3 times 2 times 2 gives us 12 different ways. Okay, if you wanted to, you could start out by drawing your 3 pairs of socks. From each of those socks, you can get 2 pairs of pants. My pants don't actually look like pants. so on and so forth, and then get your shirts that way if you want to have a visual representation of your tree diagram. Okay, so this is an example of the counting principle. So if event number 1 can occur in M1 ways and event number 2 can occur in M2 different ways, the total number of ways that you can get those to occur together is M1 times M2. Okay, so that's the counting principle that we've been using in each of those examples. Okay, cruising on. How many different ways can 5 runners, called with the ever popular names A, B, C, D, and E, how many different ways can they be awarded 5 different medals, finishing 1st to 5th places? Okay, pause the video, see if you can make a prediction. Okay, so if we're not taking into account the runner's ability and we're just trying to figure out the straight probability of the finishing, we know that we're looking for the order of all 5 places. So 1st, 2nd, 3rd, 4th, and 5th place. Okay, and the first time I choose from that group, I have 5 different possibilities. And then I have 4 different possibilities, 3, 2, and 1. 5 times 4 times 3 times 2 times 1 is 120. All right, so it's not that bad to type into your calculator 5 times 4 times 3 times 2 times 1. But what if I expanded it out and said, all right, we have 100 runners. How many different ways can we award the top 100 medals? We wouldn't want to be sitting in our calculator all day. So there's a shortcut. There's a button on your calculator and it looks like an exclamation point, and that is known as factorial. And factorial will automatically do that. When I type in 5 factorial, it'll go 5 times 4 times 3 times 2 times 1. It always starts with that top number and multiplies by each integer less than it until it gets down to 1. So here's what that looks like on your calculator. Not Google Drive, we want, oh my. And it won't go away. Come on, Mrs. Gaminar, what's happening here? Okay, anyway, so I can type into my calculator 5, and then if you're using the Graphing Calc app, you're going to tap on Math, and then you're going to look for this thing called PRB for probability, and that's where a lot of our probability functions are going to be. And I'll choose number 4 with that factorial, and 5 factorial is 120. All right, so cruising on. The spinner at the right is spun twice. How many outcomes are possible? Okay, so if we're spinning 2 times, the first time through we have 4 different choices, A, B, C, D. Second time through we have 4 choices. 4 times 4, we have 16 different choices. Okay, to try to figure out the probability that we spin A both times. Okay, so just a straight up probability of A, I see the first time through, the probability of A is 1 out of 4. The second time through, the probability for A is 1 out of 4. These are independent events. The first one doesn't have an impact on the second. Okay, so the probability that I spin A both times is 1/4 times 1/4, or 1/16. If I wanted, I could do my tree diagram. Okay, so first time through, I can spin A, B, C, or D, and then from there, I could spin an A, B, C, or D. And then I'll be lazy and copy and paste this a couple times. Okay, and for this particular instance, I'm worried about 2 A's in a row. So there's only one way to do that, and if you count them up, there are 16 different possibilities. Okay, now taking a look, if we want to the probability of spinning a C and then a D, C then a D, here's C, the only way to spin a C and then a D is like this, so we have 1 out of 16 again. If we expand on this to say rather than a C then a D, rather than we can say a probability of C and a D, where the order doesn't matter. Okay, so we could spin CD or DC, so the other one there would be D followed by C. So that would be 2 out of 16, or 1/8 of a probability of spinning a C and a D. All right. Cruising along. I don't know if you've seen this, but in like the Sunday paper or the newspaper, there's these things called a jumble puzzle. And in a jumble puzzle, the letters of the word are scrambled, and in order to solve it, you got to unscramble them to make a common word. So, what is the maximum number of combinations you could try before you discover the real word here? All right, so I have 1, 2, 3, 4, 5, 6 different letters. And I notice that all 6 of them are different. Okay, so if I just want to randomly put them into order. Okay, the first time I choose from that group, I have 6 different possibilities, then one's gone. Then I have 5 possibilities, then 4, then 3, then 2, then 1. Okay, so 5 times 4 times 3 times 2 times 1. And if you would like, you can use that shortcut of the factorial. So 6, hit up the math menu, PRB for probability, and then option 4 for factorial, and we get 720. So there are 720 different combinations before you would crack the real word. All right. Cruising on, we're going to talk about permutations, the title of our notes for today. And in a permutation, order matters. Okay, so thinking about running a race, there's a difference between finishing in the order of A, B, C, D versus the reverse order, because the person, if A is first place or A is fifth place, it probably makes a big deal to that person. All right, so on your calculator, and in that same menu where we just saw that factorial, we see this NPR button. And this is talking about taking groups of items, a certain number of it at a time. And if you wanted to calculate this out by hand, this would be the same thing as n factorial divided by n minus r factorial. Notice that we have that exclamation point symbol. Okay, that exclamation point, again, is read as factorial. Okay, so if we want to evaluate, okay, 6 items taken 3 at a time where order matters. Okay, so on our calculator, we are going to hit in number 6. Under the math button, we're going to hit up the PRB for the probability menu, and we're going to look for the NPR button, and then we'll hit 3. So here's what it looks like. Okay. So I'm going to hit 6, go into the math menu, PRB for probability menu, and then number 2 is this NPR 3. Okay, so if I want to take 6 items, 3 at a time, where order matters, there are 120 different possibilities. Okay, pause the video, try out the next couple, and then we'll compare. Okay, welcome back. We'll try out the rest. 7, permutation 4. Okay, there are 840 different combinations of 7 items taken 4 at a time. This next one. Okay, 2, permutation 5. And it's going to give us 0. Okay, which might seem strange at first. But if you only have 2 items, and you're wondering how many different ways can I group them into 5? Well, I can't make a group of 5 out of just 2 things, so the answer would be 0. Okay, and then last but not least, we're going to multiply those together. So I'm going to hit up some parentheses. 9, permutation 9, so 9 items, and we're going to take all of them. We'll multiply it by 16, permutation 2, and we get 87,091,200. All right. Cruising on. So cybersecurity here. So a specific program requires the user to enter a 5-digit password. The digits can't repeat and can be any of the 5 digits, 1, 2, 3, 4, 7, 8, 9. How many different passwords are possible? Okay, so if we count them up, we have 1, 2, 3, 4, 5, 6, 7 digits. and we want to make them into groups of 5. Okay, so 7 permutation 5, and we get 2,520 different passwords. So we want to keep that in mind. So the odds of guessing that password is 1 out of 2,520. So just guessing it. Now it depends on how good that thing is that you're trying to protect with a 5-digit password. If you had $1 million stuck in a vault and you only had to type in a potential 2,500 passwords, you might stand there and try to type in that password to get access to that $1 million. Now, on the other hand, if it was something that you had no interest in getting, you might not waste your time using that password. All right. Your job for the rest of the time is to check out the permutations worksheet. I've posted the worksheet and the answer key on Blackboard. You can also choose to do it in Class Kick, and there is also a formative on Blackboard. Okay, and you have up to 3 attempts. Please let me know if you have any questions, and I will see you online. Bye.